Okay, hi guys, it's Miss Fiona, and today we are finishing up with momentum. So, sorry, my PowerPoint's just freezing there. Okay, so hopefully by the end of this lesson, you will be able to define and calculate Sorry, just give me a sec, my PowerPoint isn't working. But hopefully by the end of this lesson, you will be able to define and calculate momentum, be able to explain impulse and answer theory questions based on it, as well as be able to do all the calculations. So today we are just going to be working through the past papers, and we are going to start with the 2018 past paper. Are you all seeing my Word document? Sorry, I don't know why my PowerPoint just died on me. Okay, so the 2018 question is question 4, and they say, initially a girl on roller skates is at rest on a smooth horizontal pavement. The girl throws a parcel of mass 8 kilograms horizontally to the right at a speed of 4 meters per second. Immediately after the parcel has been thrown, the girl roller skate combination moves at a speed of 0.6 meters per second. Ignore the effect of friction and rotation. Then question 4.1, they ask us to define momentum in words, and momentum is just a product of mass and velocity. Okay, then the second question says, will the girl roller skate combination move to the right or the left after the parcel is thrown, and name the law in physics that can be used to explain your choice of direction. Okay, any ideas? Yes, you're right, Carl. Anyone to the left, to the right? Which law are we talking about? Yep, Peter, you are right. It is to the left, and it's the third law of Newton. Okay, so when the parcel is being thrown to the right, then due to Newton's third law, every action is an equal with opposite reaction. The person will move to the opposite direction, which is left. So then for question 4.3, they tell you the total mass of the roller skates is 2 kilograms. Calculate the mass of the girl. So we are going to calculate the initial velocity, momentum, and then the final momentum. And I just quickly want to open my whiteboard. So you guys can start it so long. Sorry, just don't know why my computer. Does anyone have a quick answer yet? Or are you all? I took right as positive. You can take any other direction as positive. Okay, sorry about that. So you have your initial momentum is equal to final momentum. So my mass of my goal times my initial velocity of the goal plus the mass of my parcel times the initial velocity of my parcel is equal to mass of my goal times my final velocity of the goal plus the mass of the parcel times the final velocity of the parcel. Okay, so they have told us that the goal has roller skates that are 2 kgs. So we're gonna add that 2 to her mass, and we don't know what her mass is. So I'm just leaving it as M. And before I forget, we just say right is positive. Okay. And then her mass, velocity originally is 0, because she's standing still. Then the parcel is 8 kgs. And the parcel also had an initial velocity of 0 because she was holding it. Then she throws it. Once again, her mass is just m plus 2. And then after she has thrown it, they told us that she moved at a velocity of 0.6, but she was moving to the left based on the answer in your previous question. So it's negative 0.6 meters per second. And then they told us that the 8 kg parcel was moving at 4 meters per second. So then if you calculate this, it is 0 is equal to, and I'm just going to multiply out my bracket, negative 0.6 meters minus 1.2 plus 32. And then I'll move my 0.6 to the other side. That's mass of the goal is equal to 30.8 because you've got negative 1.2 plus 32. And if I divide both sides by 0.6, I get a value of 51.33 kgs. Well done, Carl. Did anybody else get that? We'll get to this point while you were waiting. Cool. So we're all on the same page. Then question 4.4, they ask you to calculate the magnitude of the impulse that the goal roller skate combination is experiencing while the parcel is being thrown. So just going to go back to my whiteboard. Oops. Just move that there. And so now impulse is equal to delta P, which is equal to mass times so now we're going to take the mass from here that we calculated, which is the 51.33. And remember that you have these skates in there as well, the 2 kgs. So you need to add that to your mass as well. And then we have the final velocity of the goal was 0.6, but to the left, and she had no initial velocity. So then it's 53.33 times negative 0.6. And that gives you a value of negative 31.998. And you can round that off to negative 32 Newton seconds. And always remember that 32 Newton seconds to the left. to change your negative value into a positive value by adding direction to it, because you're working with a vector. Okay, and then question 4.5, they ask you, without any further calculation, write down the change in momentum experienced by the parcel while it is being thrown. So what would the change in momentum be? Any ideas? It's going to be 32 Newton seconds to the right. Remember to add your direction to it. Then November 2017, paper 1, they tell us a 2 kg block is at rest on a smooth, frictionless horizontal table. The length of the block is x. And then they say a bullet of mass 0.015 kilograms traveling east at 400 meters per second strikes the block and passes straight through it with constant acceleration. Refer to the diagram below. Ignore any loss of mass of the bullet and the block. Then 4.1, they ask us to state the principle of conservation of momentum in words. And that is just that, the total linear momentum, in an isolated system is constant. So the principle of conservation of linear momentum just states that the total linear momentum in an isolated system is constant. Then they say that the block moves eastwards, so to the right, at 0.7 meters per second after the bullet has emerged from it. Calculate the magnitude of the velocity of the bullet immediately after it emerges from the block. So just going to go back to my whiteboard. So we're gonna say initial momentum is equal to final momentum. So the mass of the block times its initial velocity plus the mass of the bullet times its initial velocity is equal to the mass of the block times its final velocity, plus the mass of the block, the bullet, sorry, plus its final velocity. So they told us it's a 2 kg block, and originally it was stationary, so it's 2 times 0. They gave us the mass of the bullet to be 0.015 kgs, and it had an initial velocity of 400 meters per second. The mass of your block doesn't change, it stays 2, and then they told us that it moved eastwards at a velocity of 0.7 meters per second. And then your bullet's mass stayed the same, and we can now calculate that. So it's 0 plus 6 is equal to 1.4 plus 0.015 dBs, subtract that, and you get 4. Okay, so 0.015 is equal to 4.6. And then we divide both sides by, Then we divide both sides by 0.015, and we get the answer to be 306.67 meters per second. Am I right? And you can just say the bullet moves east at 306.67 meters per second. Okay, then question 4.3, they tell you if the bullet takes 0.002 seconds to travel through the block, calculate the length of the block. Okay, so they give you the time and they're asking you to calculate the distance. So what we are going to do is use one of our formulas we learned in grade 10 for velocity, distance, and speed. So I'm going to use the formula delta x is equal to VI plus VF divided by 2 delta T. Okay, then our initial velocity was the 400 meters per second plus our final velocity. And don't round off your final velocity when you're using the formula, just leave it in your calculator as is. So it would be 6, repeat it, and then we multiply it by the 0.002. And so I get 706.6. And if I divide that by 2, I get 353. Because I get an answer of 0.066 repetitively. So rounded off 0.71 meters. Am I right? Yep. Okay. Then November 2016 paper 1, they tell you the graph below shows how the momentum of car A changes with time just before and just after a head-on collision with car B. So car A has a mass of 1,500 kilometers, while the mass of car B is 900 kilometers. Car B was traveling at a constant velocity of 15 meters per second west before the collision. Take east as positive and consider the system as isolated. Then question 4.1, they say, what do you understand under the term isolated system as used in physics? So you can say anything that makes sense to you, but it should be something along the lines that it's a system that excludes any external forces. Excludes any Okay, so isolated systems in physics don't have any net force acting on them outside of the system. Then they say use the information in the graph to answer the following questions. So 4.2, calculate the magnitude of the velocity of car A just before the collision. So I'm just going to copy this and put it into my whiteboard, and it's easier. Okay, so we want to calculate the velocity of car A just before the collision. So we're going to use the formula P is equal to M times V because we are using the graph. So her P is year, 30,000 was her momentum before the collision. and her mass, or the mass, sorry, is given as 1,500 times velocity. So divide both sides by 1,500 and you get velocity to be 20 meters per second. Okay, then they tell us 4.2.2, the velocity of car B just after the collision. So we are going to use the formula momentum before is equal to momentum after. So we have car A initial plus car B, B initial is equal to Okay, so it's the mass of car A times its initial velocity plus the mass of car B times its initial velocity is equal to the mass of car A times its final velocity plus the mass of car B times its final velocity. So we're going to say it's the 30,000 because we actually already have this in terms of P because it comes from our graph. So here you've got your P initial, and over here is your P final for car A. So you can just read those values off the graph. So on this side, I will put 14,000. And then mass of car B is given to us as 900. So it's 900, and they told us that it was moving with a constant velocity of 15 meters per second west before the collision. So you'll multiply it with negative 15. And the reason we're saying it's negative is because in the bit over here, they say take east as positive, and you are moving negative. That's why we put the negative 15 in there. And then we say plus 900 times VFB. Okay, and if you plot that into your calculator, I get a final velocity of 2.78 meters per second. And it is a positive value, so for that reason, I'm going to say east. Is that what everyone else gets? Yes, no, maybe. Okay, cool. Then question 4.2.3, they ask us to calculate the magnitude of the net average force acting on car A during the collision. So we are going to use this formula, delta P, is equal to delta T F net. And if I just rearrange that formula, my F net is equal to the change in momentum over the change in time. So we are going to get change of momentum is just going to be our P final over here minus our P initial. So it's going to be 14,000 minus 30,000 divided by our time, and we're going to get our time from over here. So you look at this point over here where your graph starts going downwards to this point over here where it becomes constant again. This is your change in time. So it's 20.2 minus 20.1. That gives me negative 16,000 divided by 0.1. And if you put that in your calculator, you get a value of negative 160,000 newtons. And then you just got to remember that you got to give it a direction. So you will just say 160,000 newtons to the west. Or west, probably more English, correct in terms of English. Everyone agree? Always remember when you have negative values to please convert them to positive values by adding a direction to it, because you are working with a vector. Okay, then November 2015 paper, question 4. They tell us a bullet of mass 20 grams is fired from a stationary rifle of mass 3 kilograms. Assume that the bullet moves horizontally. Immediately after firing, the rifle recoils, and recoils just means that it moves back with a velocity of 1.4 meters per second. 4.1 asks us to calculate the speed at which the bullet leaves the rifle. So okay, so we are going to take momentum before plus, whoops, change in momentum after is equal to, okay. And we have to remember that now our masses are together. So originally your bullet is inside of your gun, your rifle. So you will put the masses together and it will have one combined velocity. And then afterwards the bullet is shot and it will have its own velocity. And so let's just say this is the bullet. This is the rifle bullet. And the rifle will have its own velocity. So your bullet is 20 grams, so it's 0.02 plus your rifle is 3 kgs, so you put that in. Originally, both of them are stationary, so it's just 0. Then once you have shot the gun, the mass of your bullet remains 0.02, and we are trying to calculate its final velocity. And the mass of your rifle is 3 kgs, and they told us that it moved 1.4 meters per second in the opposite direction. It recoiled, so it went in the opposite direction. For that reason, we are giving it a negative value. So then this is equal to 0. This is 4.2 plus 0.02. If I take 4.2 to the other side, now I just divide both sides by 0.02, and my final velocity for the bullet will have a value of, I get 210. Yes, well done, Peter. 210 meters per second. And always remember to give it a direction. So 210 meters per second to the right. And that's your answer. Okay, then they tell us the bullet strikes a stationary 5 kg wooden block fixed to a flat horizontal table. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. Refer to the diagram below. So then they just show you the bullet is coming in here, there's your 5 kg block, and then afterwards it gets stuck in the 5 kg block. 4.2, they ask you to calculate the magnitude of the average force exerted by the block on the bullet. So first, what we're going to have to go and find out is what is the time it takes for this bullet to get to where it is over there. And then from there on, we can actually calculate the force. So, because they give us the distance. So, we are going to use the formula we did previously. So, change in distance is equal to initial velocity plus final velocity divided by 2 times change in time. And so 0.4, because that was the distance it went into the block, the bullet, is equal to 0 plus 210, which we just worked out in our previous question, divided by 2 times the change in temperature. Times the change in time. 0.4 is 105 times change in time. Divide both sides by 105, and I get my t to be 0.004 seconds. Then we're going to go back and use the formula F net delta t is equal to change in momentum, which is just m times delta v. So we can say that F net is equal to mass times change in velocity divided by the change in time. And so that will be the 0.02, which is the mass of your bullet, times final velocity minus initial velocity of the bullet, divided by 0.004. And these two need to swap because my initial velocity is the 210, sorry, and my final velocity is the 0 when it gets stuck. So I get a value of 1050 newtons negative. So then you just say, that means you've got an F net of 1050 newtons to the left. Is that what everyone got? Yes, no, maybe? Yep. Okay, cool. Then the last question is, how does magnitude of force calculated in question 4.2 compare to the magnitude of force exerted by the bullet on the block? Write down smaller than, larger than, or the same. What do you guys say? Which ones are going to be the same? Yes, it will be the same. Just remember that your force, Newton's third law, the magnitude of your force will be the same. Okay, so that brings us to the end of momentum. Hopefully by now you are fine with momentum, you understand it. And are there any questions about momentum? No? Yes? Okay, cool. So tomorrow we're going to do electrochemistry. Please, 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 please go and just look at your grade 11 work. I am going to revise it tomorrow, but I don't want to spend the whole lesson revising grade 11. So please go and look at how you balance reactions in an acidic medium and a basic medium, and just redox reactions in general. If you haven't done it, like I say, I am going to explain it, but I want to try and get to the grade 12 work tomorrow so that by Friday we can work through past papers. Okay, so enjoy your day. What do you mean momentum also has work in it, Philo? Like the currency joule, or yes, you can, impulse can be used in terms of joules. Like that is its unit, joules as well, joules or Newton second. And it can be related to work, but it's normally different questions. So work will be in your question 2 or 3, and then this will just be momentum and impulse. Does that make sense? Yes. Okay, cool. So please go revise electrochem, and then I will see you guys tomorrow, same time, same place. Enjoy the rest of your day.